Hi there, my name's Carl. Welcome to my workshop and welcome to my channel. This video is a follow-on from the last one that I made, which was the Harrison Vertical Horizontal Milling Machine Restoration Part 1. In that video we talked about making a puller to assist me with dismantling the gearbox on the milling machine, actually to remove some bearing locating bushes. Now, I know the puller that I designed and I showed in the last video, and if you haven't seen that, do go back and watch it. I drew a diagram on a simple sketch rather on the whiteboard to show the design of the puller, and I'm perfectly willing to concede that it's a little bit overkill. I could have done it in a much simpler way, but the thing is, I haven't used my lathe or my TIG welder for quite a long time because I've been rebuilding the workshop or refurbishing the workshop, getting everything how I want it, and also had a few problems with the DRO on the lathe that I had to repair. So it's getting me back into the way of using my lathe again and using my TIG welder and just doing a nice little bit of machining, simple stuff, and a little bit of welding. So that's why I chose to do it this way. Now in this video we're going to be doing a little bit of simple lathe work just to make the beam for the top of the puller, and you're also going to meet someone new in this video, my youngest son Harry, who loves to be in the workshop. He's been coming in here and helping me since he was about 3 years old. He's now 7, so he's going to be helping me to do some machining on the lathe and hopefully picking up some bits and pieces and learning some things as he goes along. Now I'd like to point out that when Harry's in here he's always supervised and he always wears the appropriate safety equipment, and I take I go to great lengths to make sure that he's kept away from any rotating parts or any swath that might be thrown off. He's kept in the action, but he's kept away from anything that might be dangerous to him. So with that, I'll hand you over to Harry now, who's going to make his own introduction to the channel, and you'll get to meet him, and we'll move on and you'll see how we're going to make this part. I hope you enjoy it.
Hello, my name is Harry Wilson, my dad is Carl Wilson, and welcome to my dad's workshop.
So as I've said, part 2 of the mill refurbishment series, and we're going to be looking at making the puller that I talked about in the last episode, which is going to be used to remove the bearing retaining bushes so that we can disassemble the main gearbox on the mill. So I've taken this piece of EN1A it is, and it was previously slightly longer than this. I'd squared up the edges of a block of this block actually for another job I was doing. So I chopped a piece off the end and then I squared this end up to make the thing 70mm long in total, and it's 25 and some change wide. And while I had it in the mill, I also put in this centre mark with a centre drill, and that'll give me a locating feature for when I come to put it in the four-jaw chuck. And I'll be doing that in order to put the big spot face in, which we spoke about in the last episode, which is going to be a locating feature for assisting me when I TIG weld this on. So this tube will sit into the spot face and just give me a bit of a locating feature and a register for when I TIG weld it. So we've got a fairly motley collection of bits here, but we're going to get a useful tool out of it, I think. So this is the 304L nominal bore hydraulic pipe, and I've also got a suitable piece of M12 threaded rod here that is high tensile. Not that that really matters, but that's what I've got. So that's what we're going to make the actual the screw out of, that's going to pull the bushes out. So when I weld these together, I'm going to use 308L rod. As I understand it, it's not really the best thing to use for welding stainless to mild. Really, we should be using either 309, 312 or 310, I think, according to my research, but it's what I've got. So we'll use it and hope, and it should do a good job for us. At the end of the day, it's only going to be a posh tack really, because as I mentioned before in the last installment, all the forces when this thing's assembled are going to be compressive, so it's just to stop it falling apart. But I think it'll do a good job for us anyway. So we'll get over to the lathe now, we'll get this in the four-jaw and we'll get this big spot face put in. Now, if you're watching this video, there's a very good chance that you're the sort of person who is very well aware of this type of method for roughly centering work in a 4-jaw chuck. And if you're not, then basically all I've done is I've placed the work in the chuck on the center drill point that I showed you earlier by using the tailstock center just to hold it in position in the chuck, just to clamp it against the 2 reverse jaws. And then I brought the jaws in with a piece of aluminium packing just to protect the work. And that's it roughly centered now. That won't be a million miles away. And what we'll do next is we will bring in another center in here. We'll put the clock gauge against it, and then we'll spin the work round and we'll see how close we got. So this is the setup that we're going to use to center this piece of work in the 4-jaw chuck. Most of you who are watching this video now will have seen this type of thing done many times before, but maybe you've just stumbled across this video and you've not seen anything like this, so I'll just point out what we've got here. This is a fixed center or non-rotating center and a rotating center. The dead center is fitted into the drilled feature made by the center drill that we did earlier in the work, and then we've got this end engaged in the rotating center in the tailstock. So we can spin this work around in the chuck. We can put our indicator DTI on the end here of the dead center. The closer we are to the work, the more accurate the result is. And then we can read off the movement of the dead center, thereby giving us the concentricity or lack thereof, and we can adjust the chuck to suit. And this is a really good method of centering work in the chuck if there's no obvious feature to indicate off on the part. As long as you've got a center pot mark or a hole or a drilled center impression as the one we've got here, then you can use this method. So we'll now get on and we'll center the work in the chuck. So I hope you've got a decent enough shot of the DTI. It looks good from where I'm standing. So that's the low point there, and we'll just spin around, and that's the high jaw. So it looks like we've got, in fact we have got 0.05 of a mil run out just from setting the work up in the chuck using the tailstock center as we did. Now that's about a tenth short of 2 thou, and in some cases that would be fine, and arguably for this application it would be fine as well. And sometimes on ships I've had to set lathe jobs up in the 4-jaw like this using the tailstock center, and you don't have all the gear, you're under pressure to get the job done, and you just go with it. And I have gone with it on some occasions, and it's fine, it's absolutely fine in some cases. However, it's my workshop and I can do what I want, so I'm going to get this better than that, and when I've done that I'll bring you back and show you. Now I'm struggling to get the camera in to get some of these shots. I don't really have enough experience with positioning it, so I'm not going to try and do it and film it at the same time. So I think that there's lots of YouTube channels where you can go and learn how to set up a 4-jaw chuck, and they can explain it a lot better than I could. The basic idea is that you tighten the high jaw and slacken its counterpart, so basically you're moving the workpiece across the face of the chuck in the plane of the face of the chuck until you get the DTI to register no movement, basically, so that you're actually concentric. So I'll get this chuck set up now, and then I'll show you it once I've done it. Okay, so that's the adjustment made, and I'm really happy with where that is now. And we are now gonna take this assembly apart, and we'll get on with spot facing this part and putting a 12mm hole through the center of it. So here's a little interlude for you. For some time I've only had one drill chuck in my workshop for my mill and my lathe, and it was an MT3 arbor with an M12 drawbar thread in the end of it, and I was trying to use it for both my lathe and my mill. So what I did was I made up an ejection tang with a M12 thread on the end of it and threaded it into the the MT3 arbor on the chuck when I needed to use it in the lathe. But that was a kind of a stopgap thing that just went on and on and on, really. And I thought to myself, as YouTube stardom now is imminent over the horizon, with all 49 of you sat here watching this in rapt attention, I better get myself a decent drill chuck, or at least a half decent drill chuck for the lathe. So I bought this MT3 to B16 arbor. You can see it says there MT3 B16, and this nice 1 to 16mm drill chuck, which is also a B16. I've cleaned all the packing grease off it, and it looks like a nice item actually. I got it from RDG Tools in Yorkshire. I'm sure that most of you watching will know who they are if you're in the UK. I have no affiliation with them, other than being a very satisfied customer of theirs. I don't think that for my 49 subscribers they're going to sponsor me in any way, shape or form. But this is the box that the chuck came in, so it must be good. It says it's professional, and it also says it's top quality, so you can't go wrong there. RDG stock is mainly Chinese import stuff, but they seem to select it very well, and it does seem to be good quality gear that they sell. I've had a lot of good quality stuff from them, and to be honest with you, if it wasn't for the Chinese import equipment, I wouldn't be able to afford to have this hobby, and I don't think many of us would. So the arbor came in the standard sort of box that these things come in, and I usually keep these because they're quite good for storing drill chucks and boring bars and lathe tools and other small bits and pieces. So I'm gonna give this a clean up now, the B16 arbor, and with my methylated spirits, which is my my solvent of choice at the moment. So I'll give that a clean up, and I'll give the socket a clean up on the drill chuck, and then we'll mate these together and see how we get on with that. We'll get some methylated spirits, which I believe in some parts of the world is known as a wood alcohol, and a relatively lint-free cloth, and we'll give this a good clean. Make sure there's no dirt on it. Scrupulously clean is what I usually say about things like this. That's a great word, isn't it? Scrupulously. So we'll get that one done, and then now that that's clean, we'll do the socket. Make sure that that is also beyond reproach inside there, so that we get nothing to foul up on or to cause an inaccurate mating of these two parts. And then I'll get set up now to assemble these two together, and we'll see where we go from there. So I've got this nice big block of aluminium set up, or sitting rather, on the anvil portion of my my Swindon's vise, and I've got the drill chuck jaws inside the body of the chuck itself, so they're not going to come to any grief. So the flat of the face of the chuck is going to sit face down on the aluminium block, and the interior surface, the female portion of the B16 taper, is absolutely resplendent beyond reproach, as is the male portion. That's nice and clean as well. No chips or dirt or grease or anything else on it. It's nice and clean. Now if I put that inside there, you can actually feel that wanting to grip. It's almost getting a hold without even doing anything else. And I'm going to give this, with the old copper hammer, what's known as in this part of the UK as a good dunt. So I'll do that now. I'll put this in here, and then you might be interested to know actually that the B16 taper is actually a German standard, and it's covered by DIN 238, if that is of the sort of information that floats your boat. Right, let's make sure this is all nicely central over the anvil portion, and then we'll give it one good hit, and that should be it. Yep, that's good. I think that's in there forever now. So I suppose what I should do now, as any good YouTube machining video would do would be to put this in the mill and put a pin in the end of it and check for run out. But what we're actually going to do now is we're going to drill a hole with it in the erstwhile puller that we're making. So we'll go and do that now. So we're now in a position to put the 6mm pilot drill through the workpiece, and it's held in our nice new chuck. We've got some cutting fluid on there, liquid love, Illicut 486 mixed with some Rocol dissolved in it is what I usually use. I've got a VFD on this lathe, so I'll fire up the lathe and we'll get it up to a suitable RPM and we'll drill this hole. That's about 400 RPM now, so off we go. So that's us through. Okay, we'll change the drill bit now and we'll get the 12mm hole put through. So I put the 12mm through and I've just done a break edge, and of course I forgot to press record. So the next operation will be to machine the spot face using Clarence the boring bar. So we'll get on and do that now. So I'd like you to meet Clarence. Here he is. Clarence is a boring bar. In fact, Clarence is one of a series of boring bars. He has many brothers, some smaller, some larger, but they're all called Clarence, and the reason for that is that I once had a friend who, when we were working together, if anything needed clearance, he used to ask me if we had clearance from Clarence. And so after that, anything that needed clearance, like a boring bar, clearance to begin, boring in the initiation feature, or clearance from the workpiece, it became called Clarence. So all my boring bars are called Clarence. And yeah, I know you're wondering how my mind works. I sometimes wonder that myself, but mainly I wonder how it works at all. But now you've met Clarence, and Clarence has a CCMT insert, a 060204 CCMT insert, in fact, for you insert enthusiasts. So we'll get Clarence in position, and we'll get him set up and get him 0-0'd on the DRO, and we'll start doing the boring operation. So now you've become acquainted with Clarence. There he is, with his Fazog in his favourite place to be, his working environment. He's inside a hole, a 12mm diameter hole to be exact, that we've just drilled in this piece of mild steel, free cutting mild steel to be exact. In fact, this is BS230 M07, or I think as it's known across the Atlantic, I think it's 1214 is the spec of it. What I want to show you now is how we're going to set up the DRO to make Clarence move in the by the correct amount to get the diameter of the spot face that we want. Now you'll notice that I'm experiencing the liberty of hands-free here, or rather we're off the tripod, and it's going to get wibbly wobbly and a bit motion sickness, but it's the best way I can do it, I think, to show you what I'm going to do. So first of all, I'm going to get a touch off on the inside of this hole, just by feel. I mean, if I'd bored the hole to the final diameter, that would be more accurate, obviously, but this is going to be fine for what we're doing. So I'm just going to get a touch off on the inside of that hole, which is there, and I'll take Clarence out. So what I'll do now is, looking at the DRO, moving you over without making you feel ill, we'll 0 that. Now I know that that hole is 12mm in diameter because I've just put a 12mm drill through it. Alright, maybe not exactly 12mm, but it's close enough for our purposes. So I'm going to call X, I'm going to make X 6, because the radius of that 12mm hole is 6mm. And that means that the 60.5 diameter spot face that I want to generate on the face of that part, I can now move. In order to get that, I can now move the tool 30.25mm. So we'll do that now, and we'll see where that takes us. I've actually already done it, and I've just put a light scratch pass on the part so we can see where we're looking to our 60.5. So let's move the tool now, and we'll move it and we'll watch the DRO. So we're looking for 30.25 on the DRO. So we're getting closer, 27.5. So I'll take it to 30.25 and we'll see where we're at. See if I can get it on the first go. I did it in rehearsal. Promise. Okay, so here we go. Oh, almost. Right. Let's just take it. That'll do me. I tell you what, I'm relieved at that. Okay, so if we have a look now at the part, I don't know if you're going to be able to see. I'll come around this side a little bit, I think. It's going to block out the light, but we'll move that. This is terrible. Here we go. Right. See if I can get her to focus. So you can see the scratch pass there, I think. Perhaps. This is going to go down in history as the worst ever filmed bit of YouTube machining. Right, you can't see it, but anyway, take my word for it. If I turn it around like that, you can see the scratch pass there. That's lining up. So that's given us our 60.5 diameter spot face. So what we're going to do now is return to the DRO, and there's our 30.25, which is giving us the correct diameter for our spot face. And we're now going to zero the X, and now we can wind Clarence back to his starting position or even past it, just so he's back inside the hole. I'll show you that now, which is there. And that means now all we need to do when we want to generate that spot face diameter is feed him out until we get to 0 on the DRO. So that's nice and simple. A nice round number is 0. I think it is anyway. So I'm just going to give you a quick run around on how I set the depth of cut using the Z-axis. So I touched off using the compound to touch the tool against the work, and then I zeroed the Z-axis. Then I locked the compound so that any further movement of that is impossible. And then I brought in my micrometer stop, which I zeroed when it was up against the carriage stop here. So then my micrometer stop zeroed and my DRO is zeroed, and so the carriage is then in the 0 position, effectively speaking. So I could then wind the micrometer stop out 1 millimeter and then move the carriage back up to it again. And what that's given me on the DRO is 1.005, so I'm quite happy with that. That's perfectly acceptable. This digit's always a little bit fictional anyway, so I'm quite happy that that's set my 1 mil depth of cut, and we're ready to go with generating this spot face. Now, using the micrometer stop to do that, I find it a bit less hit and miss than trying to move the Z-axis on the carriage hand wheel. It's the rack and pinion, and it's not particularly accurate when you move it like that, and it tends to get a little bit sort of difficult to get it where you want it, and you end up faffing around with it. And I find that using the micrometer stop just takes the faff out of it. Anyway, all that said, we'll get on and we'll finally machine this part.
Today we're going to spot face this piece here in the Harrison M250, my dad's Eve. So when this gets to 0, before it gets to 0, Dad's going to tell me to push that bit back down again, and then he's going to do the rest by hand.
Okay. Right.
I'm going to like make it fair.
Slowly wind it in now. That's it. You'll hear it start to cut in a minute.
I can hear it start to cut. Why is it going?
Well, that'll be enough. Wind it back now. It's just to put a little break edge on the end, on the outside of that hole. That's perfect. Right, we'll stop the machine. Press the red button. Well, that's one way to stop it. That'll do.
And there we have it, folks. We've cut off the hard edge. So like and subscribe to watch more of our YouTube channel. Thanks for watching.
So we've now finished this fairly basic part that we're making for the puller, and I'm happy with the dimensions of the spot face, and that's going to be a nice locating feature for when we come to cut a piece of this 3 or 4 stainless tube, face the end so that they're parallel, and then we'll mate these up, put the posh tack on to hold it in position so we end up with something that looks like that, and then the threaded rod can go through. Speaking of the threaded rod, here it is. We'll cut a piece of this, we'll machine the end, we'll put the 5/16 UNC thread on it, and then the puller will be complete. So I'm going to call this video at this point because I've got about 30 minutes worth of footage now, so any more and it'll be too long. So we'll do the threaded rod and the welding and the tube in the next video. So I made a bit of a humorous comment in the video earlier on about having a certain number of subscribers. I've now actually got 54 subscribers since I've been making this. Some more people have come along, so thank you very much to the people that have subscribed, and I really appreciate it. It's going to help me to get the channel moving on and make it better. If you're watching this and you haven't subscribed, please do so for more videos and to help me to make the channel better. I really hope I haven't bored you to tears watching this. It's difficult to know where to pitch the content. I used to write and take photographs a lot and put them on the MIG welding forum, and you could assume a certain level of knowledge on there because everybody's kind of sort of singing from the same hymn sheet. It's difficult on YouTube to do that, to assess what people know or don't know who are watching your videos, and I know that the vast majority of you who are watching this now are far better than I am at machine work and general engineering. So I hope I haven't put you to sleep. The thing is, someone could come along who doesn't know anything about machining or about engineering and watch one of my videos, so I just hope that I'm putting enough in there so that people will get some kind of an idea of how to go on when if they attempt to do anything like this themselves. So with all that to one side, I think it's time for me to say goodbye, and we'll see you on the next video. Thanks for watching.